Hi, welcome to our grades 3 through 5 math carry the one event. For those of you who were just with us for the kindergarten through second grade event, welcome back. We'll talk a little bit about your older children. Those of you who are just joining for the first time, welcome. We are so appreciative that in your very busy day, you took the time to come talk to us about math. So you hopefully see on the screen, we want to know how math is going in your home. This event is about you. We want to answer all of your questions and to make math go well in your home. So tell us what brought you here. How is math going in your home? If you are here, then you have on your device, whatever device you're using, a couple of things. You have an event chat where you will see people are starting to chat in right now. Feel free to go ahead and put in your thoughts about how math is going in your home, as well as any other questions or thoughts or things that you're wondering about. You'll also see that there's a question and answer place. So if you have questions that you are really wanting us to answer today, please go ahead and put them in either place. We will take track of all of those questions. And again, our goal here is to make this event about you. So the more that you tell us what it is that you're here for, the better we can do that. So please go ahead and start bringing those questions, typing those thoughts. And we also, in addition to your questions, want to know how math is going in your home. That said, I'm Stacy Gershkovich, and I am the Managing Director of Sharing here at the Robertson Center, which is Success Academy's Sharing Wing. Our hope is to bring together parents, educators, people involved in education to make everything about educating our children a little bit easier. And so hopefully we will do that today. I also am a parent of 3. I've got a second grader, a kindergartner, and a 3-year-old in my house. And I can tell you that math is going, I don't have a word for it, but I guess a bit of a roller coaster. There's moments where I feel really good about how it's going, and then there's moments where I feel much less than good about how it's going. And the problem is you never know which one you're going to get when I go and check on my kids. So Linda, I hear you. Her child is struggling. Well, if you want to go ahead and tell us about that more, go ahead. If not, we are going to get to all of those tips and tools that we have to make this a little bit easier. And I'm not going to do that alone. I am so happy to have Kara here with me to help me and help us really get through this together. So Kara, do you mind introducing yourself?
Of course. Hi, everyone. I'm Kara Denon. I was a teacher here at Success Academy, taught mostly middle school math, but now I work on the Education Institute team, and I work with the elementary school math curriculum and assessment. So here to talk all things math for the parent who said it's their child's favorite part of the day. That is our goal, but as we're all learning, not the reality in a lot of places. So hopefully this will help.
Great. Well, thanks for joining us today, and thank all of you for joining us today. As Kara just said, this is our goal, right? Our goal is for not only your child to feel really good about math and to enjoy and be confident about mathematics, but we want you to feel really confident and excited about helping, because that's going to translate into your child being really confident and happy and joyful about mathematics. So hopefully over the next 45 minutes, we will be able to do that. This hit home with me. I came across this sometime in about March or April of last year. And so you can imagine that this was very much the way that I felt. But our goal is to change this. This should not be the case, right? Math should be something that is enjoyable, is fun, because that's what we want our kids to feel. And so we are going to hopefully today figure out how we can change that. And again, I think a lot of us are looking up here longingly for the good old days. And when I hear folks say, why can't we just solve it the way that I learned math? The way that I learned math made sense. It was simple and it was way easier than the way that you crazy teachers are teaching my kid today. I'd like to remind them of the fact that the majority of adults, when asked if they like mathematics, tell you no, right? The majority of adults, when the restaurant check comes, says, oh, you do it, I'm no good at math, right? And so the good old days maybe weren't actually that good. And that is our kind of hope today, to change that and to really get you to understand why it is that we are approaching mathematics in a different way and how that's going to help our kids change that message so that when we ask future adults whether or not they like mathematics, it is obvious that everyone just says yes. So I have on the screen a really important distinction. In all of my conversations with parents, from when I was a teacher, from when I was a principal, from me talking to my friends right now as a fellow parent, I believe that a lot of parents have this misperception about what they are supposed to do when it comes to homework or when it comes to current remote learning. I want to tell you today that teachers really don't want only right answers, only perfection, only perfect work. What teachers really want to see from your kids is effort, thinking, and they want to hear from you about how it's going. And so we're going to talk a little bit about that today, but I want to remind us that learning math, learning anything is a process, right? We've all tried to learn new things in our life, and it's not something that happens immediately. And so we have to a little bit trust the process. I'm channeling my inner LaShonda Cabbage-Stalk for those of you who have joined us for our last couple of webinars. This is a process, and we've got to trust the process a little bit. With that said, I wanted to highlight something called the Standards for Mathematical Practice. You do not need to know these. These are not for you. These are for the educators, but really important to highlight the fact that math is not simply about teaching children how to add, subtract, multiply, and divide, right? Those things are certainly important, and your children will learn those things, and it's important that they do learn those things, but we're really trying to get our kids to think mathematically. Our goal is not for them to memorize, right, a bunch of steps in that previous slide that they will probably forget once they stop doing them regularly. But instead, we want them to really understand mathematics. And so we're going for understanding. And with that, we want our kids to do much more than just be able to solve problems. We want them to be able to think like a mathematician. And so I highlighted my favorite two. It's hard to pick because I really like all of them. But I want to highlight for you today that in the end of that first one, right, the goal here is that we want our children to persevere in solving problems, right? We want our kids to struggle. When our students struggle and don't give up is when they feel really good and accomplished about the work they do, and that's what's going to get them to come back for more. And so I know that second graders, third graders, fourth graders, fifth graders, from my experience teaching them and from my experience being at home with them, perseverance is not something that we are necessarily just born with. And it's something that is a really difficult for a lot of children. And so when you are helping your child with homework or schoolwork these days, and they are struggling, I want to remind you that's a good thing, because if they learn how to persevere in face of struggle, that is going to be helpful for them in life. So with that, I hope you're convinced that a little bit our approach to math is not so bad. But I want to give you a couple of tips that, a couple of really concrete things that you can do at home. And these 6 questions that I'll read for you in a moment that you see on the screen came from one of my favorite educators, math educators, a man named Steve Leinwand, who we've worked with for many years and has given us lots of great tips, but the ones that stuck with me the most are these 6 questions that we use in our schools and that we want to encourage you to use at your home to say to your child when your child is doing math homework. How do you know? Convince me. Explain that, please. Prove it. Draw a picture, and why. You'll notice that all of these questions could be answered, could be asked about any question. They're very open-ended questions that apply to any question your child is solving. And these are the 6 questions that we ask in our classrooms to really encourage students to talk about math and to share their thinking. And so what we're going to do in a moment is to model for you. Kara and I are going to act as though Kara is my daughter and I am the mom, and we are going to practice what does it sound like when I support my child who is trying to solve math problems, which is what you are here today to learn about. So with that said, we're going to practice. Kara, again, I said, is going to be a student. I am going to be the parent, and I am going to try to figure out what Kara is doing. This is not about me understanding the mathematics, right? Maybe you were okay with kindergarten math. Maybe you were okay with first grade math, even though it looked a little different. There is a point where the mathematics is going to become unfamiliar. Even if it is familiar, the way that students are learning mathematics is likely unfamiliar to you. The goal here is not for you to learn all of the math that your third, fourth, fifth grader is doing. It's really about getting your kids to be able to explain the math in a way that makes sense and that you feel confident that they know what they're doing. So with that said, we're going to try this out. You're going to notice that I am going to stick to these 6 questions to the best of my ability. And even though I've been doing this, teaching with these questions for quite some number of years, I have them written in front of me, and I would encourage you to do so. With that, a special reminder, this all is being recorded for you to come back to later. Will be shared with you in an email, along with a really nice little cheat sheet with these questions for you. So don't feel like you need to have them all memorized. We will be sending them to you right after. But let's see how I can use these 6 questions to understand a little bit what Kara is doing. So there's a problem. In a moment, I'm going to stop talking and I'm going to ask you just to read it. Think about how you would solve the problem. If you want to think about how your child might solve this problem, if your child's with you and they want to solve the problem, that's fine. If you want to solve the problem, that's fine. If you want to use a calculator to do so or any other tools that you have, go for it. Take a minute, think about this problem, and then we're going to role play in a second. Okay, so there's 6 boys and 5 girls at a picnic. If each boy gets 1/4 of a sandwich and each girl gets 2/4 of a sandwich, how many sandwiches will they eat all together? Okay, Kara, I see you solve the problem. Can you tell me, convince me that this is the answer, 11 sandwiches.
So there are 6 boys and 5 girls, so that's 11 people, so I need 11 sandwiches. But that's not right. They don't get everyone doesn't get a sandwich, a whole sandwich.
Okay, I see you're kind of thinking about something. Can you draw a picture? Maybe that could help. Wow, you were quick, Kara. Okay, so Kara, I see some crazy squiggle lines, some people, some have arms, some don't. I don't understand. Can you tell me what you did here?
Okay, so I went back to the question and I realized that not everyone gets a whole sandwich. So I needed to figure out how many whole sandwiches they get, but they each got pieces. So I tried to draw it out. This first square on the top left are 4 boys because they each get 1/4. I split it into fourths. But there are 6 boys. So then there are 2 more boys at the top. And they get the top of that second square. But see on the bottom of that, that's a girl because they get 2 of those little pieces because they got 2/4. And so then the bottom are 4 more girls getting 2/4 and 2/4. So altogether, I need these 6 boys eat 6/4, and those 5 girls eat 10/4, and so together that's 4 sandwiches.
Okay, well that crazy drawing now makes sense to me. Thanks for sharing. So often we'll ask our students to solve the problem in more than one way. So I've asked Kara to solve the problem in a different way, and she came up with this. Kara, I see that your answer is 4. Can you convince me?
Yeah, so on the top line is where I'm getting the boys. And I know that each boy eats 1/4 of a sandwich, so I need to add 1/4 6 times. That gets me to 6/4 or 1.5. Then the bottom is the girls. So each girl eats 2/4. So I have to add that 5 times because there are 5 girls. And that gets me 2.5. So I added those two amounts together to get 4 whole sandwiches.
I can see exactly what you did there. Okay. So we're going to do one more. We're actually going to do 2 more, but here's the next one. Again, I want you to focus on, it's not about, I'm going to go back for a second, it's not about you solving the problem the way your child does. It's not about you being able to draw these drawings. It's about you being able to understand how your child got the answer and you being convinced that that's a correct answer. So you saw me using the words, I think I said, convince me. Can you convince me? And that was what prompted Kara to kind of have to explain her crazy, lines and drawings and fractions. So let's try it again. Here's another problem. Take a moment, read it, solve it. Think about how you would solve it. If you want to go ahead and solve it, that's fine too. If your kid is nearby, you want to have them solve it, that's fine as well. Use any tools that you have, go ahead. Okay. Well, let's see, Kara. Oh, you got fancy. You did 2 different ways before I even asked. Okay. Seems like you listened to your teacher. Oh, I've seen those hops before. How do you know? Oh, so Kara, what's your answer?
My answer is 46 tables.
How do you know that?
Because I added on the number line and then I divided.
Ah, so it's not 2 different strategies. I see. It's actually one strategy. You said you added on the number line. Can you explain that, please?
Yeah, so in the problem, it said that there were 194 men and 217 women. So I needed to know how many people there were total. So I started at 194 and I added 6, 210, and 1 to get to 411 because that's 6, 210, and 1 is 217. So there are 411 people.
Okay. But then you weren't done. So can you convince me about the next part?
Yeah, so I know I have 411 people and they're going to sit into tables of 9. So I need to figure out how many tables of 9. So if I have 40 tables, that's 360 people. That's not enough tables. So then I had to do 9 times 5 to get 5 more tables, and that only got me to 405. So that means that there were going to be 6 people who didn't have a seat. So I had to add 1 more table. So even though I have extra seats, I need 46 tables in order for all of them to fit.
Oh, I see exactly what you did there. And thanks, Rebecca. We've got a request. Can you go back to this 194? So you were adding from 194, and you started with adding 6. Why did you do that?
I did that because it would be easier for me to do the rest of the problem if I got to 200 and I didn't have to deal with all the hundreds, tens, and ones. So I knew that 4 plus 6 got me to a 10, and that was 200. And so that was like a friendlier number for me to then do bigger groups of 20, 10, and 1. I think depending on the grade though, a scholar could get to 200 and then realize I have 211 left and just add 211 in one group. That's also fine, but going that 6 makes it easier to make a bigger jump that next time, because adding 200 to anything is a lot easier than adding 194 to something.
So I think what we're trying to highlight here is that the way Kara solves it is the way she thought about it. It's not the way you must think about it, right? There's lots of great ways that kids would think about it that make sense to them. And so she used these friendly numbers. You'll see our students do that a lot, that they want to think about ways that they can make the problem a little bit easier. And so they know that they can take apart that 217 and break it down into pieces, right? The 200, the 10, the 1, and the 6 is the same as 217.
And I think that's a great question, like already, like why did you make the jumps that way? That's a why question that gets your kid to explain their thinking a little bit. So that's using the questions to kind of like push their understanding of their strategy even further. So whoever asked that question, great. You're already getting it.
Great. Okay, so you solved it in a different way. And again, we wanted to just show different ways that kids will solve it, not because we want you to understand all of these, but because we want you to get comfortable hearing different solutions that students have. So Kara, go ahead. I see you circled your answer, 46 tables. Can you convince me that that's the answer?
Yeah, so I knew that I had 411 people because I added them. That's the part on the left. And then I needed to figure out how many tables of 9 people I needed. So I took that 411 and I did not know how to divide 411 by 9 in my head, but I did know how to divide. I do know 36 divided by 9 is 4. So 360 divided by 9 is 40. But that wasn't 411. So then I divided 45 by 9 to get 5. So that's 45 tables, but I see over here that I still had 6 people left that weren't in that 360 plus 45 gets me to 405. So I had 6 people left. So I had to put one more table in to get those 6 people to have seats.
And I love how Kara explained that. Often kids won't explain that part. So if you notice that there's some kind of extra piece of information, you can just ask, I see that you have 6 people left over. Can you tell me, why? Right? And that will get them to explain their answer a little bit more. All right. Let's try one more. We're going to do one first. 45 times 16, I imagine you probably could take out a calculator and solve it. I'm just going to quickly show you the way that most of us as adults would probably solve this problem. This might look really familiar to you. That's probably not the way your child will solve it, particularly if they're closer towards the 3rd or 4th grade range. So let me show you something that you probably will see a lot of if you haven't seen already, these boxes. So Kara, the problem was 45 times 16. What's going on? Can you prove this? Prove to me the answer is 720.
Yeah, so I didn't know how to do 45 times 16. So I had to break it up into facts that I did know better. So I split it up by place value and I multiplied all those things together.
Convince me that you did that.
So I had 16. I split that into 10 and 6. I had 45, so I split that into 40 and 5. I multiplied 40 times 10, 40 times 6. That would be the 40 times 16. And then I did 5 times 10, 5 times 6. That's the 5 times 16. And then when you add them all together, so 400, 240, 50, and 30, I added those all together to get 720.
That makes totally sense. And since I solved it myself as a parent before, I see the answer's also the same as what I did. And so her explanation makes sense and the answer seems right. Nope. Now we got to our favorite, decimals, right? 5th grade parents, decimals is a challenge for our students. Let's see how we can make it a little bit more familiar. Well, that looks familiar, Kara. I've seen you do that before. Can you explain this, please?
Yeah, so 45 times 16 is similar to 45 times 1600ths. I've just changed the 16 into 1600ths. So it's 16 over 100. So instead of getting 720, I just had to divide my answer by 100 to make it 100 times smaller.
Okay, and then you did it kind of similar, but a little different at the bottom. Can you explain that bottom strategy, please?
Yeah, so the 45 stayed the same, but this time I didn't want to take away the decimal. I just left the decimal point in there, but I still split up my number by place value. So I had 1/10 times 40. So 40 times 1/10 is 40 tenths, which is 4. And then I had to do the same thing with all of them. 5 times 1/10 is 5 tenths. And then 5 times 600ths is 30 hundredths or 3 tenths. And then I needed to add all of those up, being really careful that I added the ones place to the ones place, the tens place to the tens place.
No, I see exactly what you did there. Thanks for sharing. Okay, phew, we're gonna stop. We're gonna get out of our parent child scenario, and I just want to kind of reinforce some certain things that we spoke about today. Math is supposed to be a time where kids learn to fall in love with mathematics. Certainly, while doing so, we want them to also learn how to be great mathematicians and add and subtract and multiply and divide and fractions and decimals and all of those things. But we really want to make sure that the best way to get our kids to be better at math is to get them to love math. So take a deep breath. We got to be positive. We want to emphasize the effort that our kids are showing, not only just the right answer, but what is the work that they did to get there. Often we kind of show our best effort and we don't get the right answer, and that's okay. Use these 6 questions. Again, we'll mail them out to you after the thing. Have them in front of you and go back to those. We want this to really encourage students to think and not for parents to give their knowledge to kids, but really for kids to grow their own knowledge by answering the questions and being forced to think a little bit about what they're doing. And then again, your teacher is there and wants to hear from you. So if you're noticing your child is struggling or you are struggling or not sure what to do or what your teacher expects from the classwork or the homework that they've been assigned, ask them. Ask them if they want always the right answer, or ask them if they're okay if their child has the wrong answer, if they can submit it like that. So with that said, we're going to go over to our question and answer. So I'm going to stop sharing, and I know some folks have already shared some questions in the Q&A box. If you haven't had a chance to do that, now's your chance. Kara is going to bring to us all of her expertise as a teacher, and I will share some of my advice as a parent and as a former teacher. How can we make this a little bit easier for you? So if you have a burning question, if there's a struggle that you are specifically having, please go ahead and put that in there. And with that said, we're going to get started. So Kara, this is a common one. My child doesn't know where to start. So they're given the problem, the timer starts, counting down, and my child is kind of staring at a blank page. What should I do?
Yeah, so this is a common one, and I think it also relates to one of the things that we talked about earlier, where I had done like a totally wrong strategy. At first, I think a similar thing can be done there. I like asking a kid to visualize what's happening in the problem, reread it, visualize it, figure out what the story is, act it out, model it, draw a picture. Those are all things that they can do to kind of just see math in the problem. And another thing is just a lot of times, like you saw with these problems, especially in 3 through 5, there's a lot of information in there. So getting them to pull out, instead of focusing on what they don't know or I don't know how to start, try to reframe it to become a little bit more positive, like, what do you know? Go back, reread the question. What is it telling you? What do you know? Where could you start? And just, I think even jotting down some of the facts that they do know about the problem will give them a place to start. And then you can have a conversation, even if it's not a complete strategy about one thing. But I also think giving them time to draw a picture, model it, and then come back a few minutes later is also very helpful.
Yeah, and I would just encourage you to resist the temptation to tell your child where to start. Right? It's our temptation to say, well, why don't you try doing this first and see if that helps you? The hardest part about mathematics is usually figuring out where to start, right? Once we know where to start, our kids are pretty good about actually solving the problem for the most part. And so try and resist that temptation to tell them where to start and instead focus on those things that Kara just shared. What do you know? Can you draw a picture? Can you tell me about the story? Let's try acting it out. All of those strategies will help your child really build their muscle on figuring out where to start. So just resist the temptation, although I know it's tempting. Okay. Oh, this is a good one. I say this because my child fits into this category. What about a child who just gets so frustrated? They're given a problem. They just get frustrated and they kind of throw the pencil down and they're done, or the stylus, I guess I should say today.
So similarly to like what we just kind of talked about is, I think even as like a learner myself, like sometimes taking the space to like, okay, I'm frustrated now, I can take a break for 5 minutes and come back to it with fresh eyes later. Like just like incremental things like that is one suggestion. Like in a classroom, just sitting down and staring at the page, if you're frustrated, you're kind of going down a rabbit hole again. So take a step back, take a deep breath, go for a walk, and then come back and try to figure it out. But like you have like 5 minutes to kind of get yourself together and then come back. As just a human, that's what I like to do when I get frustrated. But then another thing is just like, I would also take note of some of the content that they are getting really frustrated with to kind of keep that open line of communication with the teacher. Potentially it's that like your scholar needs extra help on fractions and your teacher can kind of give you extra materials there if you're ever noticing it's like a trend. Stacey, if you want to jump in.
Yeah, I think what I do with my child who kind of falls into this category is really focusing on small goals. And so, a child might get frustrated with the blank piece of paper. And so a goal for that day might be, or for that week, every day during math time, I want to see something on your paper, right? I want to see what you do know on the paper. I'm not right now worried that you're going to get all the way to the answer, but I am worried that when I come and check on your math homework, or math work, whether it be during math time or whether it be later in the day, I want to see something on that paper, right? Once you can get your child to get something on the paper for a couple of days, and you celebrate the fact that they did that every day, don't forget that part, that's the most important part, then you can say, okay, every day I saw that you put something on the paper, right? Next week, I want to see at least one day that you've solved the problem all the way through, even if the answer is not correct, right? But that you've actually came up with an answer for every problem that you're given. And so that will really encourage the child to get something out there, even if it's not right. More often than not, the child will get a lot of right answers, right? We want to get them over that fear of having a wrong answer. Wrong answers aren't bad, right? We're taught to kind of fear wrong. And really what we do in mathematics class is wrong answers are good because that tells us a lot about what you're thinking and gets us to understand the math in a better way. So don't be afraid to put a wrong answer on. Once your child can get an answer on every day, then you can move kind of each day. But small goals and really celebrate your child's progress so that they don't feel like they need to tomorrow do it all, but break it down in little pieces. And certainly your teachers are there to help with you. So if that's a problem your child is having, reach out to them and let them know what you're thinking or ask them for their advice so that you guys can be on the same page and that they can also celebrate your child having something on the paper versus nothing. Yeah.
And I think that is just a good point about the effort is like you can't a lot of times, besides saying like draw a picture, a lot of these like conversations happen when a kid starts something. So that's just like progress to get them to do that. But then if they're not showing anything, their teacher, because they're not even in class with them now, their like touch points are the work that the scholar produces. So whatever you can get them to put on the paper, their best effort is best, but to give their teacher an idea of what they are struggling with to help them be also less frustrated if it is like a content gap issue, that they can actually be aware of it and help them in the way that your kid needs to be helped.
Yeah, 100%. Again, the wrong answers are going to be like a sign to teachers that we need to do this again, right? And if your child's always handing in right answers because you help them get them there, it's not going to help the teacher really know what your child needs and what the kids in the class need. So good advice. So yeah, this math is really new, and I'm worried that the children aren't learning the basics anymore, right? When do they get to learn the basics? Are they going to learn the basics? Are the basics even important right now? Like, will my kid learn how to multiply, divide, add, and subtract, fractions, decimals, etc.?
I think that's a really, really good question. And one is like a fifth grade teacher. I got a lot from parents because it is like the culmination of all these strategies that you see in elementary school, like the area model or partial products, they all come together. And then in that grade is where scholars learn like the standard algorithm. But like as an adult, I actually find partial products much more easy for me to do like in my mind than like taking out a piece of paper and doing the standard algorithm. So like the basics look different, but the basics are happening in terms of like understanding the reasons why you're doing what you're doing to eventually get you to that point. So while it looks different, the basics are happening at a slower pace to build number sense in a more strategic way. I also think sometimes like it seems like the basics aren't being covered because homework and classwork are not just calculation problems. They're number stories. You have to figure out what's happening in the question. But that is like the meat of math and the heart of math. It's not just can you do multiplication or can you add and subtract. It's can you figure out why you're even adding and subtracting in this problem? Why is this problem even telling you it's a subtraction problem? So to the point that Stacy was making before on the math practices, it's like constructing an argument for why you're doing what you're doing. And if you don't understand why it's a subtraction problem, if you know how to subtract, that won't help you. So that's why we're kind of trying to do all of those things in our questions at the same time. They're not isolated. So I think those are two factors that kind of go into that feeling. But eventually they will get there and formalize those strategies. But those strategies are going to be harder for your scholars if we skip those kind of intermediate steps.
Yeah, and I think your 2 points are exactly right. I think what we are realizing as educators is that a lot of the reasons students struggle in higher level mathematics is because they don't have a really solid foundation in the younger grades. And so when students get to calculus, calculus doesn't look so different than it did when we were young. But what we realize is the reason people are struggling with calculus so much is because they don't really have a true understanding of all those building blocks that will help them with calculus and algebra and all of those things that they get to later on. And so again, trust the process. The students really are going to benefit from having a foundation of understanding that they can then build upon and use as they get older. The other piece that I just want to kind of reemphasize is that I lost my thought. Something about how to solve. Someone once said this quote to me, and it just, whatever you just said reminded me of it, is that I've never found, the quote is something to the effect, I'm going to butcher this, but that I've never found a problem that was worthwhile my effort in solving if I already knew how to solve it. Right? And I think that applies here. Like, how fun is mathematics if I already know what I'm supposed to do? Right? Really compelling problems are problems that we actually don't know how to solve. And all of the work is in figuring out how to solve it. The actual solution, solving it, is the quick part. And so just encourage you to think about it like that. getting to understand how I'm going to solve is really where our efforts need to be. Okay, and what about when my child's assignments cover content that they haven't learned yet, they say they haven't learned yet? What do I do?
I think this is a great time to like utilize the teacher as a resource because like if it is potentially a mistake and it's a question that's like beyond the scope of where they are, that's good for the teacher to know because it's going to be across the board in the class a problem. But it also is helpful for you to know if it is something they've learned and it's like a spiral that they're coming back to that your scholar may have forgotten or had a gap in the year before and didn't come up. I think that's also important to know. But I think here is the time when I think to Stacey's point before, we want to resist the urge like, oh, you never learned it, but your teacher's expecting you to do this. Here's one way to solve it. But instead, try like use those strategies to get them to try to figure it out. But I think the most important thing to do is if that is the case, reach out to the teacher to let them know because potentially it's something they need to review because the teacher the year before didn't cover it and they need to like touch on it again, or it was like an error or something. But I think that's kind of where I would go.
And I would encourage you to be skeptical a little bit. I know I have a second grader who will tell me that they never learned any of this stuff. And so use those 6 questions, see if you can get them to understand a little bit about it and see if you can really just get them to think more about it. It might be the case that they truly never learned about it, but be skeptical. Ask them what they do know, if they can figure out how to get started. And see how far that could take them before or in addition to reaching out to the teacher.
Yeah, because I also think sometimes it might look a little bit different because the context is different, but the math inside it is the same, and that's kind of the point of the question. So I think digging into visualizing it and what do you know is super important there because I do find that happens a lot. Is like kids think they don't know because it looks very different to what they've done in class, but it might just be a slightly harder question of the same understanding.
Yeah, great. Well, amazingly, our 45 minutes is coming to an end. Kara, thank you for bringing all of your advice and wisdom here. It was certainly a pleasure to have you. And to all of you who joined us today, thank you. This is a really hard time for parents. There's ups and downs. It's a bit of a roller coaster, but I would just encourage you to really think about how you can use these 6 questions to your advantage and focus on making math enjoyable and fun for everyone, using your teacher as a resource. And I am confident, like the fact that you are here today is probably a sign that you are doing everything right. So thank yourself, give your kid a big hug, and good luck with it. We know you got this.